Andrea Albanese is going to be presenting on enabling autonomous navigation on UAVs. And we can go ahead and start, Andrea.
Okay, good afternoon, everybody. Thanks for the introduction. I will present you how to enabling autonomous navigation on drones with onboard MCU-based camera running tiny machine learning models directly at the edge. The authors of this work are Marcus Profunser, me, and my advisor, Davide Brunelli. The idea to enable autonomous navigation is to use arrows and symbols written on the ground to suggest high-level actions to drone. The workflow of this system is composed by a camera, which retrieves frames. Then each frame is processed with an ad hoc video preprocessing algorithm, which extracts region of interest that may include arrows. Then these region of interest are given as input in the arrow direction prediction algorithm, which given the prediction of the direction of this arrow to enable the navigation, thanks to the flight controller of the drone, toward the detected direction. The first three tasks are running in the OpenVCam H7+, which is an MCU-based camera. This algorithm, this machine learning algorithm, is executed directly on board on drones with an edge computing approach. Thus, it is possible to boost its performance and meet a real-time execution. It has been developed with a custom dataset with 8 classes, accordingly to the polar coordinates, such as north, northeast, east, and so on. And we have collected 26,000 images for training and 6,700 images for test. And a few examples of them are shown in these figures. And finally, we have trained this algorithm with the 3 different CNN architectures, LeNet, MobileNet, and SqueezeNet, in order to compare a big, medium, and small size architecture. In order to fit the camera memory constraint, which is about 500 kilobytes, we have performed a few model optimization techniques. In particular, we have performed before training model architecture optimization by reducing their convolutional layers. And after training, we have performed cascade pruning and float fallback quantization. The results of these optimization techniques are summarized in this table. And it is possible to have the memory optimization versus the loss in accuracy. And it's possible to notice that even if the model is highly compressed, the loss in accuracy is negligible. Thus, in conclusion, model optimization techniques don't compromise accuracy, and it is possible to say that the bigger the models is not always the better. Moreover, a consideration about the system energy consumption is taken into account. In fact, considering a small size drone and an always active camera consuming 240 milliampere at the 3v3, it reduced the drone available energy only by 4% less. And finally, it is possible to have a demonstration of this algorithm. And thanks for the attention. Now I'm open for questions.
Thank you, Andrea.
I want to thank our sponsors that made this event possible. So the premier sponsors, Newton, working on automated TinyML. If you were there a few days ago, they had a keynote explaining what they're doing. Executive sponsors are ARM, Edge Impulse as well, and Qualcomm, Sentient, and then our platinum sponsors. We have Infineon and Reality AI. Gold sponsors are Latent AI, SensiML, and our silver sponsors are EMSA, Greenwaves, HOTG, Imagimop, GISO, Seed, and ST. And with that, I thank you very much for staying on till the very last end, the last day of the last session of the last day. And with that, I think we can close the forum for this year. Thank you everybody for contributing. Thank you, Andreas, for also moderating this session.